rest of this paper. So let's have a look at this question. It says find the equation of the perpendicular bisector of the line segment PQ. Give your equation in the form y equals mx plus c. So first of all, I am going to draw a line where it joins P and Q together. So the line is going to be roughly like this, but it wants us to find the perpendicular bisector of this line. So the perpendicular bisector is going to cut this line in half. What do we know about this perpendicular bisector? Well, we know quite a few things. First of all, we know it's going to have a negative gradient. Why? Because we can see it's going downhill. Another thing we know is it's going to have a positive y-intercept, because we can see if we continue the line, it's going to cross the y-axis at quite a high point, roughly at 20 or 30. So how do we find the equation of this perpendicular bisector? Well, first of all, I'm going to label the coordinates. They're quite easy because they're given in the question. 4, 8 and 10, 10. Now, this is a very set process which you also need to be able to do in Voronoi. So how do you do this? Well, one of the first things you're going to do is to find the midpoint between the 2 points. To find the midpoint between the 2 points, we're going to add together the x coordinates and divide by 2, and then we do the same for the y coordinates. So 4 plus 10 divided by 2 is simply going to be 7. Then we're going to add together 8 and 10 divided by 2 is 9. Lovely. The next thing we're going to do is we're going to find the gradient, but we're going to find the gradient of PQ. The gradient of PQ is simply going to be y2, which could be 10, minus y1, divided by x2 minus x1. So how do we do that? It's going to be 10 minus 8 divided by 10 minus 4. How do we get that answer? It's going to be 2 over 6, or 1/3. Now, for the next mark, what we would do is we'd get the gradient of the perpendicular bisector. So I am going to call this the perpendicular bisector. I'm going to call it PB. So let's now find the gradient of PB. To get the gradient of PB, we just take the gradient of PQ, we flip it, and then we change the sign, so it's clearly minus 3. Finally, how do we get the equation? We bring it all together, we substitute in minus 3 into y equals mx plus c. Then we choose the midpoint and we substitute that in. So we're going to get the 7 and we're going to get the 9, and we're going to substitute it in. So it's going to be 9 equals minus 3 times 7, which is minus 21. Then we're going to add the c, and then rearranging c is 30. So I had a really good guess earlier that c was roughly 30, and that made it beneficial for me to draw the diagram. So the answer is simply going to be y equals minus 3x plus 30. You can see I've completed that problem really quickly. Now I want you to have a think about how to complete part B. Determine the coordinates of the point on the road where the bus stop must be located. So, in order to do this, we need to make sure we read the question. 2 post offices are located at points 4, 8 and 10, 10 on the graph below. A road represented by the line R, which is this one, passes near the post offices. An architect is asked to determine the location of a bus stop such that it's the same distance between the 2 post offices. So clearly it's going to be here, because at this start point it's going to be equidistant to both P and Q. So how do we find that out? Well, all we need to do is we need to find where 2 lines intersect. So I'll show you exactly how to do that. So in order to find where these 2 things intersect, we're going to take this equation, and then we're also going to take the equation here, and we're going to see where they both cross over. So let's do that. We are going to rearrange the secondary equation so it's written as y equals something. So it's going to be 7y equals 40 minus x. How do we then solve that or simplify that again so it's in a similar format to that? Well, we're going to divide both sides by 7. So now it becomes minus 1/7 plus 40 over 7. And we've obviously missed out the x, so I just need to include the x here. And we just need to see where these intersect. You can just do this by putting them on the calculator, or you could do this algebraically. Let's double check the mark scheme for this. If we double check the mark scheme, we could find the answer. The mark scheme is here, so let's scroll through and we're going to find the relevant question. You can see in order to find where they both intersect, it's going to be 8.5 and 4.5. This is the first higher level question. Let's go on to the next question. This is a function, find the range of f. Okay, the best thing to do for this is to get open your TI-84 calculator. Here is the TI-84 calculator. In order to find this, we're going to put this function in. But remember, you should really include brackets for the fraction because a lot of people forget to include brackets, which means it sometimes does go wrong. Okay, so I'm going to go over now question 11. How will I go over question 11? We are first of all going to have a look at the kind of question it is. It says we are checking out a t-test. Now, a t-test is really straightforward in terms of the null and the alternative hypothesis. For all these kinds of tests, the null hypothesis is always going to be HO and the alternative is H1. For a t-test, the null hypothesis is always mu1 is equal to mu2. Now let's study the question for the alternative hypothesis. It says the t-test was used to compare the means of the two groups, and it doesn't say anything about one being bigger or smaller here, but it does above. It says the carrot in his field, the gardener, is greater than at the supermarket. So we're going to say the gardener is mu1 because it's the first listed in the table, and the supermarket is mu2. So we're going to then put that as the alternative hypothesis. So it's going to be mu1 is greater than mu2. Then we are going to find the p-value of this test. How do we do that? All we do is we open our calculator. We are going to go onto the stat list. We're going to press edit. We're going to clear both of the lists. So we're just going to press clear on list 1. And then we're going to do the same on list 2. And all we do is we just type in the values. Once you've typed in the values, you just press stat, calc, tests. You're going to go down to 2 sample t-tests. We are studying the data because it's in list 1 and list 2. We put list 1 and list 2. We put 1, 1. We want mu1 to be bigger than mu2. So we select the third option. We can have an explore and have a look at question 11. The P is going to be this. So how do we come to our conclusion? Our conclusion is comparing P to 0.05. So the comparison would be as follows. You are going to take whatever the P is, which is here, and say whether it's bigger or larger than 0.05. Here, it is a big P. So this is the way I would remember it. Big P means we accept it. So big P means we accept it. Big P means we accept HO. And we do. So you either say accept HO or you say reject H1. Or for some reason you can do a double negative. Do not reject HO. But I think the easiest thing to say is just accept HO. Let's go over the next question. It's to do with triangles, which look like right angle triangles because we've got the right angle at the bottom. It says to find the distance from B to Q. How do we do that? So first of all, I'm going to take a look at the larger triangle, and it's going to be a right angle triangle. So this is the right angle triangle here. There we go. We have got this nice large right angle triangle. Then we have got the 500 and then we've got the 45. We just need to apply SO, Ka or TOA. This is going to be the opposite. this is going to be the adjacent. There we go. So it's simply going to be tan. We have a look at the triangle. It's going to be TOA. We simply want to find either O or A. We want to find O because we don't know what O is going to be. It's distance from P to Q. So we just do tan of the angle. So tan of 45 times by tan of 45 times by 500. Make sure your calculator's in degree. Make sure you include the brackets. Easy. Let's now do the question where it says find the distance from P to Q. P to Q is just simply this triangle. How would you do that? Well, I would actually think of the smaller triangle and then minus it from the bigger triangle. So this is our smaller triangle. This time we're looking at the green triangle, and I'm going to erase previous workings out because perhaps you're going to get a little bit confused with our previous workings out. So this time when we're checking out the smaller triangle, we are studying some slightly different numbers. We're this time using the 45. Instead of using the 45, we're going to be using the 30. So let's annotate the diagram appropriately. This is going to be the opposite. This is going to be the adjacent. So how do we do that? Well, in this particular problem, we still want to find the opposite, but this time we're going to just replace 45 in the tan 45 with 30. So we just do tan 30 times 500, and then that's going to give us the distance from B to P, but we want to find the distance P to Q. So we just get the answer from part A and subtract it from this answer here. So let's just double check with the mark scheme, and that should be quite straightforward with how you get the final answer. You can see, there we go. We just get the answer from the previous question, which is 500 minus the answer we've just calculated, and you get 211.32.